Hi everyone, good morning. So today we are going to start with our second LOS, second learning chapter. So time value of money in finance. Uh, Second chapter of quantitative methods. Before we start, let's discuss what we are going to study in this reading. So the first LOS of this reading is calculate and interpret the present value of fixed income and equity instruments based on expected future cash flows. So expected future cash flows, I'm emphasizing on this word because this is the very first LOS which we are going to discuss. So expected future cash flows. Just remember this thing. The second LOS here is calculate and interpret the implied return of fixed income instruments and the required return and implied growth of equity instruments. So return for fixed income and growth for equity instruments given on the present value and cash flows. And the third LOS here is explain the cash additivity principle, its importance for no arbitrage condition, and its use in calculating implied forward interest, forward exchange rates, and option values. So let's get started with our first LOS. So first LOS, calculate and interpret the present value of fixed income and equity instrument based on expected future cash flows. So expected future cash flows, what does this mean? So if you remember from your elementary school, so how does a bond functions? So let me just give you a brief overview of what does a bond mean. So bond is basically an instrument which has a feature which actually mimics features of a loan or debt. Bonds could be issued at a value which so there are three types of bonds: bond issued at premium, bond issued at par, and bonds issued at discount. What does premium, what does par, and what does discount mean? So premium means above face value, at face value, and discount means below face value. And what does face value means? Face value means the amount which you are going to get at FV is the amount at maturity. So assume that you are a company, you are an organization, and you actually have issued a bond to raise money from the market, or you could be government. So you are a company. You are some company, some organization. So you are actually raising money from the market, and you are paying back to the investor in the form of coupon payments, timely payments, or think about it as an installment time EMIs. And there is a rate of return. When we talk about bonds, that rate of return is actually yield. We refer to that. So just it's just a fancy term to use. The rate of return. It represents the rate of return. Face value means you are raising you money, and at the end of the tenure, you are going to buy back that bond from the investor at face value. So the company is going to, you are going to buy back the bond at maturity from the investor. And this I'm telling you not in technical terms, but in layman terms. So how does it works? Let's assume there is a bond. You have raised a bond for 5 years. Time zero, 1, 2, 3, 4, and 5. So every year you are going to pay. the coupon, there's a bond which comes with a coupon payment of, let's say, 10%. Coupon payment is 10%. Coupon is 10%, and yield, which is just a fancy name for return. I'm saying that yield is 5%. So the bond, the face value of the bond is $1,000. These are our numbers. So what we are going to receive here, if you remember, I emphasized on future cash flow, cash flow, cash flow, cash flow. Everything is, when we talk about finances, when we talk about present value and future value, we are talking about cash flows. So cash flows are very important when we're talking about valuing something. So if something doesn't have cash flows, you are not valuing that. You are actually pricing it. So there's a difference between valuation and pricing. Okay, so at the end, you are going to receive $1,000. Yes, you are an investor. I'm asking you, at the end of the tenure, you are going to receive $1,000. You are going to receive 10% coupon. This means 10% of 1,000 is at every year end, you're going to receive $100 coupon payment. This is your coupon payment. $100 coupon here, $100 coupon here, $100 coupon here, $100 coupon here. And at the end, you're going to receive actually $1,100 along with the coupon payment. So this much you are going to receive throughout the tenure of the bond. I want you to answer me, how much are you willing to pay today? The present value of the bond today. So what you're going to do is, the formula is very simple. What you're going to do, the logic here is that the yield is 5%, the rate of return. And we discussed about this when the first chapter was rate of return. The rate of return was the very first chapter which we discussed. So now this is how actually everything is linked here. I'm going to give you a holistic approach here. From a holistic approach, I'm trying to make you understand this thing. This yield, this yield of 5%, how the rate of return is calculated. Now your concepts are being tested. So rate of return is risk-free rate, inflation, default, liquidity, and maturity. This is also what actually decides the yield of the bond. Now, the formula is simple. Present value is future value raised to the divided by 1 raised to the power rate to the power time t. And this is the formula. I have changed the formula to calculate the present value. The formula which we read in our school, in our elementary education, was future value is present value 1 plus rate to the power time t. So this is the formula when we use when the frequency of compounding is annual, maybe annual. This is basically annual. Uh, when the frequency changes, we change the rate and the time also. We divide the rate by the frequency and we multiply it with frequency here and frequency here. We have discussed about this in our previous LOS. If you have missed that LOS, just go to that LOS and watch it. So I am assuming that the frequency of compounding here is annual, but just a one case scenario, it could be more than annual. But what if the frequency of compounding is continuous compounding? When we talk about continuous compounding, this in this very equation, only this factor changes. So the when we talk about continuous compounding, the one plus r the okay, let me just give you the formula. The future value is one plus future value is present value. We multiply this thing present value with e raised to the power rate into time. And there, uh, what is e and how do we calculate e? Let's not talk about this because this is just going to confuse you. We actually have a function in our calculator where we actually have a function here. Here we actually have a function e to the power x. We can use it. We click on second first. We click on this number. So we are able to access e to the power x. So all these functions above your keys, these are in yellow color. And to access these functions, you actually have to click on second if you want to use those functions. If you want to use normal functions, these keys, you can click on these numbers. But if you want to access the functions above your keys, you actually have to click on second. How do we calculate it? You click on it. Okay, we first plug our rate into time. Then we click on second and we then click on e to the power x. First, second, and third. This is the third step. We will talk about this when we'll do a question. So e to the power x, this is the formula for continuous compounding. How do we calculate the present value here in this function? In this situation, the present value. So now expected future cash flow. Now understand cash flow. So what we are going to do is we are going to discount this 100 coupon to the present value here. We are going to discount this here one for 1 year. We are going to discount this for 2 years, 1 year. We are going to discount it by 2 years. We are going to discount this for 3 years. We are going to discount this future cash flow for 4 years. And we are going to discount this 11 this $100 for 5 years, and we are going to discount this $1,000 separately for 5 years. We will add every value here at time zero, and this is going to give us our present value. And we actually have a function to calculate to bypass this whole calculation in our calculator. So let me just show you my screen. Let me just share my screen and let's discuss about this specific question in our calculator, in our uh, BA2 plus financial calculator, the online version. So to calculate these functions, the present value questions, whenever you are doing present value questions, present value and future value question, time value of money questions. So you are going to use this line. N represents number of year. IY represents interest slash rate, interest divided by rate. So this is this is where you plug in your yield or your interest slash yield. Present value, this PV represents present value. PMT represents any payment. So if we will use PMT function in case of EMIs, each month in equated monthly installments, or in case of there is a withdrawal or there is a deposit in those kind of situations. And FV represent future value, not face value. So be careful. And remember to follow the positive negative convention here. So if there is a cash inflow, try to consider it as a positive number. And if there is a cash outflow, you actually have to command the calculator that it's a negative number. This is a cash outflow. So I will recommend you to please pay attention to this thing. Uh, Please always use the negative or positive signs when you are plugging in numbers. because if you do not do this, so calculator will assume that these are both cash outflows. So the value, it will not be able to calculate the value correctly. So our question was, there is a coupon payment of $100. This is the payment, and there is a coupon. There is the face value. Uh, Interest rate time. I said that the interest rate or yield is 5%, and the number of years is 5 years. So we are going to compute the present value, and the present value is 1216. This means the bond was actually, this is actually a premium bond because the investor is willing to pay 1216.47. So the bond which we discussed about, this was a premium bond. And what if I am saying that the present value, how will the present value change? If I say the interest rate is 10% from 5%, and if I say compute the present value, so the investor is only willing to pay $1,000 to the bond, and this means the bond is issued at par. And also remember, here the coupon payment is equal to yield. In our earlier example, the coupon payment was greater than yield. And let's say the yield is 15%. So what would the investor be willing to pay the future? How much what would be the present value? So today you are going to pay how much for this value, this bond? So 832.39 you are willing to pay. This means the bond is discount, issued at discount. So here the coupon payment is less than yield. So yield is greater. Okay, let me just go back to our notes. Let me just show you one more time what I have written here. So in this case, in this situation, in case number one, case number two, and case number three, I here the coupon payment was 10% and the yield was 5%. Here the coupon payment was 10% and the yield was 10%. Here in this third case, the coupon payment was 10%, but the yield was 15%. So this is something we have discussed everything, this whole chapter in a nutshell here. This will be helpful for to you when we will discuss about fixed incomes. This will be this concept. So coupon payment, when coupon payment is greater than yield, the bond will be issued at a premium. When the coupon payment is equal to yield, the bond is issued as at par value. This means that given this situation that I will be getting $100 coupon payments and $1,000 at the end of the tenure, I am only willing to pay $1,000 for the specific bond if the yield is 10%. The yield, when the yield increases, the bond, the value of the bond falls, the present value of the bond falls. I hope you have understood the overview here. So what we are going to discuss in this reading is there are different type of bonds. First, we are going to talk about fixed income instruments. So fixed income instruments, there are discount bonds. This means we have discussed about pure discount debt instruments. We have discussed, okay, zero coupon bonds means there is no coupon payment. So how will you value a bond? And simply in our calculator, what we are going to do in these kind of bond, the PMT is going to be zero. There is no coupon payment. This means the PMT is zero. So the bond would be differently valued. And this is the simplest kind of bond. Fixed coupon bond, we have discussed about fixed coupon bond. Perpetuity bond. Perpetuity bond means those bonds do not have a specific life. So in those kind of bonds, we use the formula rate payment divided by rate, and this is how actually the present value of a perpetuity bond is actually calculated. Then there is a different kind of bond, amortizing bond. So amortizing bond is that bond which pays a level amount each period, including its period maturity period. The difference between amortizing bond and a fixed coupon bond for that is that for an amortizing bond, each payment includes some portion of the principal. So here, if I am saying I am paying you a certain portion of principal along with the coupon also. So if I am paying you a certain portion of coupon principal along with the coupon payment, how would you calculate the present value of that bond? And for that, the the logic is simple. Don't get confused with the formula. With the formula, we will discuss when we will do a question on the amortizing bond. Don't worry about it, and I'll try to make it as clear as possible. I hope from this example you have recalled or understood, uh, recalled what you learned in your elementary education, and you are able to, you have understood what I am trying to deliver here. Okay, so let's do one question. Let's say there is a bond, the zero coupon bond issued at a yield to maturity of 6.7%. What would be the investor willing to pay for this bond? So this is a question. Here we are going to calculate the the face value here is $100. The bond, actually the time tenure, the future value is $100. The tenure time is 20 years. Okay, let me just use different colors so that it's little visible. So the time 0 and time 15. At time 15, the future value is $100. Investor expect to pay for this bond per INR of principal, $100, 100 INR of principal, or $100 of principal. Uh, it could be multiple of $100, 100 in Indian rupees. So don't get confused. Just let's take one scenario and try to figure it out. So if the future value here, the future value and the face value is 100, uh, the time is 15 or 20 years. Time is 20 years. The yield to maturity, which is the YTM or the IY function, IY, I slash Y is 6.7%. And this is a zero coupon bond, so PMT is going to be zero. What we need to do is we need to calculate the present value here. Understand the question first. What would an investor expect to pay for this bond here? So they are asking the question, "Hey, today, what would be an investor willing to pay?" I'm sharing my screen, my calculator now. We will just plug in the numbers. Okay, before you reuse your calculator after calculation, always remember to clear your work. Click second and clear work. Click second and clear work. Make this a habit. uh, so that all the functions which you have previously used, the calculator cleans that up. Okay, let's start. Future value is $100. There is no payment, so I'm going to plug in zero. Interest or I slash Y. interest yield is 6.7%. N is 20 years. The frequency is 20 years. I'm going to compute, press. What I actually want is compute, and I want the calculator to compute the present value. The present value of this uh, is 27.33. 27.33. So this is actually the investor is going to pay 27.33 INR, euro, yen, uh, any other currency, yuan, any other currency. And yes, the 27.33 is actually a very alarming number when we talk about $100. But now understand this thing. This is how actually the time value of money concept works. You invest 27.33 rupees today, or 27.33 uh, dollars today. So this is going to give you $100 at the end of 20 years if the yield to maturity is 6.7%. The calculator computed all this. The calculator also computed in the similar manner. We can do a Excel. We can calculate this using an Excel function. Manually, it's going to be very time consuming. So this logic, this whole process, actually, the calculator saved you this much time. So here the tenure is 5 years, but the tenure was 20 years here in this question. And when we talk about coupon rate, so let's do another question since we are talking about it and we have discussed uh, the theory part. So let's discuss the questions, the examples first of this specific reading. I'll try to uh, make sure that nothing is missed. So coupon bond, a coupon rate. Okay, the coupon rate of a bond is 4%. This means coupon rate of a bond is 4%, and the payment is made once a year. The frequency is annual. Time to maturity is 5 years, and the market discount rate is 6%. This is your I/Y interest yield 6%. What is the bond price per $100 of par value? Okay, previously also they have asked us what is the at $100. So this means that if per $100 means, so if I'm saying you that at the end of the future value is 1,000, so what you are going to pay? So if I'm saying per 100 it's 10x, so you are also going to pay 27, sorry, the present value. So there you are also going to pay 10x of the present value. The present value is 10x is 10x of future value. If it's 15x, so 15x of future value, uh, 10x of future, 15x of your present value. So this is what the question actually means. So the don't be don't get confused. This is just a way of saying things. One more thing about CFA is before you start answering the question, just read the question and try to understand what the question is asking you to do. I'm not saying that these are riddle questions or these are tricky questions, but they are actually testing your concepts. And to answer CFA questions, you actually need to have a clear understanding of the concept, even if it's theory, or uh, even if it's numerical questions or theoretical questions. You actually need to have clarity, and the devil lies in the detail. Just understand this thing. Okay, let's talk about our second example. So coupon rate is 4%. The coupon rate of the bond is 4%. So we are going to calculate our coupon rate. So coupon rate is $4 is the PMT here. Uh, and IY is 6%. IY is 6%. This is the future value FV. Time, where's the time? Time to maturity is 5 years. This is our end. N is equals to 5. So how are we going to calculate this thing? So this example is actually mimicking this thing which we discussed here. So this is the coupon payment. So every year you get a coupon payment of $4. Coupon plus uh, uh, when we talk about at the end of fifth year, you are going to get 100 plus 4. So this is 104. The present value of this 4, let's do this question on our calculator. So what the question is saying is the present value, how do we calculate the present value? So the 4, so 4 is the present value. Let me just take you back. So how do we calculate the present value? So present value, we are going to discount the first 1 by 0.06. This is the formula for present value. Future value discounted to the rate of, discounted with the rate. The second 4 we are going to discount it by square of 1.06. The 4, the third one we are going to do cube. 4 by 1.06 to the power 4 and 104 to the power 1.06 raised to the power 5. And this is what we are going to plug in here. So this is 1, this is 2, this is 3, this is 4, this is 5. Why are we doing this? Because to use calculator, to use anything, a tool, before you use any tool, you need to understand the basic logic behind it. So now I'm sharing my calculator with you. So 4, we are going to divide 4 by, let's do one thing, 1.06. I'm going to uh, inverse this and I'm going to multiply it with the 4, 3.77. This is our first cash flow, 3.77. Now uh, clear my calculations. Second, clear. 1.06 raised to the power 2 inverse multiplied with 4. This is going to give me 4. 1.06 square inverse multiplied with 4. This is going to give me 3.56. 1.06 raised to the power 3 inverse multiplied with 4. This is going to give me, I don't understand why it's giving me incorrect value. 1.06 into 1.06 inverse into 4. 4 divided by 1.06 divided by 1.06 divided by 1.06. 3.36 is the right answer. 3.36 is the right answer. Okay. Now, one more time, I'm going to divide it by 1.06. This is going to give me the value for fourth year, 3.17. And now I need to divide 100 divided by 1.061, 1.062, 1.063, 1.064, and 1.065 for the fifth year. So this is going to give me a value of 74.73, and I divided 100. I actually had to discount 104. 1.061 divided by 1.062 divided by 1.063, 104. Let me just okay, so if I calculate it 104, it's going to give me 77.71. And if I add everything, it's going to give me a present value of 91.56. So this is what I am willing to pay for a coupon rate, a bond for every $100 with this cash flow. So if the bond is going to give me a $4 coupon payment, and my principal at the end of the tenure. So today I'm willing to pay $91.56, 91.56 rupees for that bond. This means the bond is at discount. And one feature which you would have understood is here the yield is greater than the coupon. Yield is greater than the coupon means yield is greater than the coupon means the bond is issued at discount. And okay, one we have some time, so we can also discuss what does a perpetual bond looks like. So this example is for a perpetual bond. So a bond pays an annual coupon rate of 10%. So coupon rate PMT is $10 at the end of every year forever. So for if there is no time, there is no factor. The time doesn't. So we do not have any. The bond doesn't end. The cash flows of the bond doesn't end. So we are going to use perpetuity here. Calculate the present value of the bond assuming the market rate of interest is 5%. And the formula for perpetuity is payment divided by rate. So what we are going to do is we are going to divide payment divided by rate 0.05. And this is going to give us a bond. The present value of the bond is $200. So we will discuss about the other questions in our next reading. All right, so that's it for today. Thank you for attending this session. I hope you have understood the perpetuity bond.